Let's do one more problem with these mole conversions. This one has an extra step, so we'll have to be careful to watch it. For one thing, when you see a problem and it involves number of molecules, you should automatically think about Avogadro's number as a tool that you might use. And always in chemistry, think about molar mass, grams to moles, grams per mole, because that is used so often. Now both of these numbers have 2 units and 2 numbers, so I'm not going to start with those. If I have a choice, and I do, I'm going to start with the 50 grams of nitrogen in 2. Okay, so I don't want grams of nitrogen, so I'll put grams of nitrogen here. What will I convert to next? Well, as I told you in chemistry, if you can convert to moles, then do, because that's often a first step. From moles you can get to other things. And so to do this, I'm going to use the molar mass of N2, atomic weight 14 off the periodic table. So the 28 goes with the G, so down here, that's per 1 mole. Next step, so my grams cancel. I need moles down here. And what should I go to next? I'm trying to get to number of atoms, and I know that Avogadro's number tells me the number of atoms in 1 mole. So I could go to, let's see, 1 mole has 6.02 times 10 to the 23rd. And then this is a mole of N2, which really is into molecules, a mole of the molecules. So this is molecules, not atoms. And I didn't write that out here, but notice this time I was very careful to put what it was a grams of. Grams of N2, not grams of nitrogen atoms. Grams of N2, moles of N2. So I can see that at this step I really don't have my answer. This will give me how many N2 molecules, not nitrogen atoms. I need to do another step. So this was my Avogadro's number step. But one last step. I need to go from nitrogen molecules to nitrogen atoms. And where do I get this? Using the formula, N2. I can see that for each molecule I have 2 nitrogen atoms. So that's the new step. Sometimes you get a conversion factor just by looking at the formula. Let's get an answer for this. Am I going to expect a really big number or a really small number? We're talking about 50 grams. You know, 50 grams is something you can hold in your hand and definitely see. I'm going to expect a really huge number of atoms. And there we go. I tell you to kind of check those predictions because the most common thing to mix up is Avogadro's number. And if you get this upside down, it will throw this number way off. It'll look unreasonable. So anyway, there you go. There's your last example.